Hi, my name is Carson Pierce, and today I will present my PowerPoint on noise in pavement. So the outline for this PowerPoint will go introduction into the causes, then material properties, related equipment, cost implications, safety considerations, uses in Texas, a summary, a conclusion, and then a little test your knowledge, and then references. So, an introduction, noise in pavement refers to unwanted sounds generated by vehicles, machinery, or anything that goes down the road, highway, interstate. This presentation will show a little bit about the factors that contribute to that noise, including the material selection, surface texture, and construction methods, which can vary between states and organizations. We will also examine the impact of noise reducing pavements and that cost and that safety and community well-being, with some examples that we use here in Texas. It's important to understand how to mitigate pavement noise because it can create a more safe, more sustainable environment and highways that protect the drivers, construction workers, and the nearby residents. So, what causes noise in pavement? Many things can cause it. Um, the main ones are the type of pavement used, the texture of the pavement, the construction methods and activities that were used to build that, the maintenance of those roads, and then treatments that can be added on. So, material properties, what are roads made of, or what could they be made of? They could be made up of asphalt, which is a mixture of bitumen and aggregates like sand and gravel. Porous asphalt is actually best for paving. There's also concrete roads. There's also can be base materials underneath that concrete or asphalt. Roads can also be made of recycled materials of like old asphalt and concrete. And then there's also geosynthetics, which is synthetic materials like geotextiles. So, how do those different materials and properties affect noise in pavement? So, asphalt is a lot quieter than concrete due to its smooth surface and its ability to absorb sound and reduce tire pavement interaction. Porous asphalt, as I said, is a lot quieter and it helps to drain the water and air more efficiently. Now, concrete is louder because of its rigid surface. Again, the texture. It does not absorb sound very well. The joints and surface textures, like tinning, can increase the noise. Those things that are done on concrete can often make roads louder. But there can also be smoother finishes, such as diamond grinding. The base materials, this creates a more stable base, which can in turn help with smoothing of the surface. It helps prevent cracks, potholes, which ultimately reduces sound over time. And then the recycled materials, it performs similarly to asphalt and concrete because that's what it is. And then geosynthetics, these materials are really good. They improve pavement stability and prevent deformation, which ultimately helps with a smooth, quiet surface. So, related equipment. I kind of broke these down into noise measurement tools, construction equipment, surface texturing tools, surface friction testing. So, for noise measurement tools, they use a decibel meter, which measures the sound levels that is created by the vehicles driving on the pavement. Sound level analyzers are very similar. They record the sound levels, but also the frequency ranges. And then you have tire pavement noise testing equipment. which tests the noise levels of different objects and vehicles driving over different type of materials and properties. And then you have construction equipment, paving machines, with the construction of the roads. You have the compactors and rollers. You have the surface finishers. You have the paving machines for porous asphalts, which are different. And then you have vacuum trucks. And then for surface texturing tools, as I said a while ago, you have the tining machines, which create the grooves in the concrete, which help with traction and with water absorption, but that does create more noise. Then you have the diamond grinding machines, which smooth out the concrete, which helps reduce the noise. And then you have grooving machines, which cut out channels that help with the drainage of the rain, but also can add some noise in there. So that's kind of a hit or miss. Then the surface friction testing. Equipment like skid resistant textures measure the surface friction of the pavement, which directly correlates with noise. So when you have higher friction, you usually have higher noise. Maintaining that surface texture with that equipment is key for noise safety and noise reduction. Cost implications. So, asphalt versus concrete. Asphalt is generally less expensive to install than concrete, but noise reducing asphalt, like the porous asphalt that I've been talking about, can cost more due to its specialized materials and installation techniques. Then quiet pavement technologies like diamond grinding for concrete, using the porous asphalt, those involve additional cost because they are better quality and they use different equipment. And so all of those things can be more expensive, but in general, asphalt is less expensive than concrete. So long-term maintenance cost. Asphalt requires a lot more frequent resurfacing compared to concrete, which can add long-term cost, but also the noise-reducing asphalt surfaces may deteriorate faster, leading to higher maintenance costs. So there is a hit or miss with that. You can have noise-reducing asphalts like the porous materials, but you are going to pay more in the maintenance. For concrete, concrete's typically more durable, but may require costly surface treatments, again, like the diamond grinding over time, to maintain that smoothness, to reduce that noise. And repairing concrete joints that have cracked or moved, that can be quite expensive as well. Now, for the porous pavements, which are best, that is needed regular maintenance, like the vacuum cleaning trucks, to prevent clogging of pores, which can increase the cost of those. Safety considerations. So there's a couple different areas of safety that we are going to talk about. So driver safety. So the quieter the pavements are, helps minimize those distractions, allowing drivers to focus on the road and drive better for longer distances. Improved communication. The lower the noise levels are, the more drivers and emergency vehicles can hear. You can hear emergency vehicles coming and other warnings and just overall driving safety. Then for pedestrians and community safety, noise population reduction, quieter roads improve the quality of life around those interstates and highways. It can help cyclists and pedestrians walking hear better so that they can know when danger is coming. Crosswalk safety, reduced pavement noise helps with crosswalks, with pedestrians being able to hear cars coming and things like that. So surface quality and vehicle handling. Quieter pavements are typically smoother, which enhances the vehicle handling and reduce the risk of accidents, due to potholes, uneven roads, anything in that area. And then enhanced traction, that helps with icy or watery conditions, helps you control the vehicle better, which reduces accidents. And then joint safety. Properly designed joints reduce sudden noise and improve vehicle control, enhancing the safety of the driver, the drivers around them, and the pedestrians in that area. For weather-related safety, again, that porous asphalt helps to drain water and reduce hydroplaning risk, which improves the control of wet conditions. Reduce splash and spray, quieter, porous pavements minimize visibility issues during the rain, so drivers are able to see the road better and there's not that reflection off of the water sitting on that pavement. So how does this implement into Texas? So in Texas, we have Texas Department of Transportation, which is Texas DOT, which encourages the using of noise reducing pavements to address traffic noise concerns. They have created guidelines for choosing quieter materials. They have funded projects to test for their effectiveness, and they encourage the use of noise reducing pavements. So, a couple porous asphalt projects here in Texas. I know Houston implements that a lot. San Antonio implements that a lot. We use it a lot on our highways to reduce noise and improve stormwater drainage. In our cities here in Texas, we have roads going over each other, under each other. So, that civil part of that has to be really good. And then the quiet concrete pavements, it's used in urban areas like in San Antonio, Austin, and I'm sure in Houston as well. These projects use reinforced concrete to improve the durability and reduce noise, which enhance the driving experience and the residential areas that are around there. Um, Texas universities and research institutions are involved in ongoing studies to evaluate the performance of noise reducing pavements. These studies, they analyze the longevity, the cost effectiveness, and the overall community impact, helping to guide future projects and helping to motivate the use of noise reducing pavements in the future. So, just a little summary of what I just presented. Understanding pavement noise. Tire pavement noise impacts driver comfort and community well-being. This is influenced by the materials, the properties, the surface texture, and the construction materials used in the creation of the highway of the pavement, um, and so forth. Key materials. Asphalt is generally quieter than concrete, with surface texture and joint design significantly affecting noise levels. Equipment's role in this. Specialized tools for equipment, paving, and finishing directly impact the final pavement surface, which is a direct correlation to noise. Cost implications. Noise reducing pavements may occur higher initial cost, but long term, they are savings through the reduced maintenance and societal cost related to the noise population. Safety considerations. Quieter pavements enhance safety by reducing distractions for drivers and improving awareness for the pedestrians and communities around. Texas implication. Texas has adopted noise reducing pavements and projects such as porous asphalts and quiet concrete, showcasing a commitment to addressing community noise concerns and a hope to get better in the future. So, in conclusion, the management of pavement noise is crucial for enhancing driver comfort, safety, and community quality of life. Investing in quieter pavements not only yields immediate noise reduction benefits, but also long-term economic and social gains. Ongoing innovation in materials and techniques combined with community engagement will help ensure that future projects prioritize noise reduction, ultimately creating safer and more sustainable roadways for all, especially in Texas with our infrastructure. So here is a little test your knowledge if you have been paying attention. The first question is, what are the primary factors that contribute to tire pavement noise? The second question is, which type of pavement materials is generally considered to be quieter? And then, what is one benefit of using porous asphalt in highway construction? I'll give you a second so you can read those and answer those. And then here are my references. Thank you all for listening, and thank you for presentations that I have just given you. I hope you have learned a lot, and I hope you have a great day.